Welcome to our conversation today about longevity and aging. What's so super about superagers? I'm so glad you could all join us for the latest in the Live Better Longer series. Today we are talking about superagers, people who have lived past their 95th birthday. I'm Kaitlyn Phoenix, Deputy Editor of the Hearst Health Newsroom, which produces content for Good Housekeeping, Women's Day, and of course, prevention. Live Better Longer is brought to you by AFAR and Prevention. AFAR is a leader in making sure science happens, and prevention is, I think, one of the very best platforms for learning about science. There's so much fascinating research being done around aging that I'm excited to learn about and to share with you through these conversations with researchers and other experts. Today, we'll talk about what science is learning about healthy aging from those who have lived the longest among us. I'm honored to be talking to Dr. Nir Barzilai, Co-Investigator of the AFAR SuperAgers Family Study, as well as Natalie Ramirez, a 95-year-old, energetic, and very proud grandmother and great-grandmother in Florida. Dr. Barzilai and Natalie, thank you both so much for joining me today.
Pleasure.
Dr. Barzilai, let's start with you. Let's before we get into superagers, let's talk about aging. Is aging flexible?
Yes, absolutely yes. And that's why is our marriage with the prevention part of the magazine, right? Because look, we know that aging has a biology because we know who's old and who's young. What people don't realize is that this biology drives diseases of aging. And so if it drives diseases of aging, we want to interfere before we get diseases. And in laboratories all over the world, we went from hope that something we can do about it to actually prove that aging, as you said, is flexible, that we can target this process of aging, and by targeting it, we can delay this biology and delay variety of age-related diseases so we can live healthier for much longer.
Aha, that makes perfect sense to me. And can you explain what you mean when we say exceptional longevity?
Well, exceptional longevity, people can decide on their own. What I've started years ago is another superagers study. This is the big one of taking people who were healthy when they're 95 years old. Now, there are people who are exceptionally healthy when they're 85. That's also okay. You know, half of us die by the age of 80, okay? So people who passed 80 and they're still healthier are less and less, but there's a lot of them. So we have kind of examples of people who achieve really great health and great age. And as long as both those things happen, they can have fun until the end of their lives.
Aha. And some people might say that having people live longer puts more stress on everyone else living. What are your thoughts on that?
So, look, I'll give example from, my superagers study that was kind of the preliminary to this one. We recruited 750 centenarians and their children and family. It's a whole, we might get to it later. But we were concerned, and what we wanted to know, the first thing is, do they just live longer? Or do they get diseases when everybody gets their disease? You know, we kind of accumulate disease at age 60. We get the first disease and its treatment, and the second disease and its treatment, and the treatments are interacting with each other. So are they just sick for 40 more years, or did their health span and lifespan, did it go together? And we found out that it did. And quite dramatically, they were not only living healthier, they were living longer. But that wasn't really even the most interesting thing. The most interesting thing is that they had compression or contraction of morbidity. It's a term that suggests they were they were sick very little time at the end of their lives. we're sick 5, 8 years at the end of their lives, and they were like 30% of them even didn't have any disease when they were 100 years old. And some of them just didn't wake up one morning. So we started to think about the concept that's called longevity dividend. What happens if really we can use this example and say, we're going to make you live healthier and live longer, and one day you won't wake up? What does it mean? Interesting, the CDC, and we all know what's the CDC after COVID, right? The CDC was looking at the medical expense in the last 2 years of life of somebody who dies over the age of 100 versus those who die, when they were 70. And it's third the cost. And our 100 years old, when they were 70, they even didn't go to the doctor. And so what I'm suggesting is that being healthy is actually not a burden on the economy, it's a saving for the economy. And in fact, there's a guy, Andrew Scott, who's a professor of economy in London Business School, and he said, guys, you don't know what you're talking even. You're totally underestimating, because you're saying the medical cost, okay, so this guy is not in the hospital, but what is he doing? He's traveling, he's shopping, he's getting houses for his kids. So there's an economical value for being healthy. And this is, in his calculation, $360 trillion within the next 10 years. It's something that we cannot afford not to do. So even for this economical reason, of course, everybody wants to be healthy, but even for this economical reason, if we can imitate those superagers, okay, we're going to have not only more happy people, but we're going to have benefits for the economy. And this cannot be understated.
I'm so glad you pointed that out, because I feel like so many people don't think about that aspect, that these people who are living longer are living healthier, which is great. And I want to remind everyone else who is tuning in, if you have questions along the way as we're chatting, please feel free to put them in the chat box, and then we will get to some of them at the end. To continue our conversation, I was wondering, how did you get into studying this topic?
So, for me, aging was really the major problem that I could see. I remember walking with my grandfather when I was 13 years old, and he told me what he did when he was young. And I was like, how is it possible? We look at our grandparents and we don't see us being them, right? We're like, where did they come from? What happened to them? And that's how I looked at that. And I said, what is this aging thing? And even when I went to medical school and became a doctor, and I knew that cholesterol is important, and I knew that blood pressure is important, but I couldn't look at that audience and see who has high blood pressure or high glucose or high cholesterol, but I could see who's old and who's young. And this was really a major thing. There were no aging experts or aging biology expert. I went to become an endocrinologist because I thought, there are all those hormones that are changing with aging. If we'll just fix them, it'll be great. It happened not to be true, but I got a really good biological education, so I can ask the bigger questions.
Gotcha. That's so interesting. And so far, what have researchers like yourself learned from studying centenarians or superagers? And what
say it right only when you're 100 years old.
Right. And what questions still remain?
Okay, so we had 3 major theories. One is that those centenarians, they got to be this age because they did everything right. They didn't know what's right at that time, but maybe they happened to do everything right in their interaction with the environment. And we quickly found out that that's not the case. 50% of them were overweight or obese, 60% of the men and 30% of the women were heavy smoking. Exercise, even moderate exercise, even housework or biking or walking, less than 50%. So it wasn't about the environment. And in fact, that was when we published this paper first, it was a joke. Jay Leno at the Tonight Show made a joke out of it because he said that the secret to longevity is to be obese, to stop exercising, and of course that's not true. But it's really important that our centenarians, as a group, they got to this age in spite of not interacting with the environment, right? I have a woman who I argued until her last day, which was when she was 110 years old, because she was by then smoking for 95 years. And I said, nobody told you to stop smoking? And she said, all the 4 doctors that told me to stop smoking, they died.
Oh my
Okay.
goodness.
And the point is not that if you smoke 95 years, you live a long life, which will be true, but that for them, it didn't matter. Why it didn't matter? Because they had genes, they had changes in their DNA that were slowing their aging. So they slow it to such an effect that those risk factors didn't really add anything to them or not much to them.
It makes you wonder how much longer she would have lived if she hadn't been smoking.
And that was always the argument. But, at a certain point, I hope that I live as long as her. So I wasn't arguing. But when you ask centenarians themselves, you can ask Natalie what she thinks. The first answer comes, it's in my family. My mother was 102, my grandfather was 108, and you kind of understand that there's the genetics. The woman who smoked for 110 years, she had 3 other siblings that died between the ages 102 and 109, right? So it was in this family. And so this is very important for the superagers because we know that there is a large genetic component to that. And this is what we are trying to identify. But I also want to emphasize, why are we doing it? And people might say, well, too bad that you can find gene, but I don't have a gene like that. And I don't want gene therapy. But, we're finding those changes in the DNA, those genotypes, what we call, or we are finding them in order to find the mechanism by which aging is slowed. We have already 2 drugs that were developed in part based on our finding. The fact that in centenarians, we had several genotypes that had functional consequence. We could measure what they do in the blood, and they were already turned into medicine, once by Merck Pharmaceutical and another by Ionis Pharmaceutical. And so the thing is, our findings could be translated into medicine. And we believe that since our centenarians live kind of 20 years below the average, that those things that we're discovering will add a lot to an increased health span and lifespan for the rest of us.
So interesting. Could you tell us a little about the SuperAgers study and the methodology, and who are the participants and what you're doing with the study?
Sure. So what we want to do is we want to have somebody who's over the age of 95 and basically lives independent or can actually pass a very basic cognitive function test. And what we want mainly at first is a sample of their DNA. How can we get a sample of DNA? They can spit into, we'll send them an envelope and they can spit into a tube. And we have enough DNA from that, okay? But that's not enough. We want also DNA from their children, because remember, their children are endowed. By the way, I shouldn't say children, I should say offspring, because when we first got this permission from the IRB for the review board to do this study, I had a letter saying, I'd like to study centenarians and their children. And the package returned the next day saying, for children, you need different forms. But of course, the children of centenarians are 80 years old, right? So they can take care of themselves. They don't have kids. So it's centenarian and their offspring, because their offspring have, half of their longevity, right? Components in them, or the genetics of that. And those kids, we're using those kids in my study, that is the current study, and we're finding some really amazing thing. The offspring of centenarians are biologically about 10 years younger than the people they are married to. So what we want is, we want the offspring of centenarian and somebody that they are married to. This will be a control for the environment, and probably also control for the, for the population. If you're Indian, we want to have enough Indians. And if you're Asian, we want, we want to have a good reflection of the community. So we take the offspring and the people who are married for them. But I started saying those offspring are 10 years biologically later. They had less cardiovascular disease and less cognitive decline and less mortality, right, than their control. So we want to create 10,000 of those. Okay, we want to create 10,000 of those, because if we have the genetic of 10,000, we're just much more likely to validate our finding, to find all the longevity genes, and to really start manufacturing drugs based on our findings.
And is this the triad that you talk about? The three?
Yes, that's the triad. So we need centenarians, one of their offspring, and a person who's married to their offspring.
Gotcha. This makes perfect sense. So you want to have all of that data to be able to compare and see what could be the environment, what could be genetics, all of that.
Right. And but remember that the offspring of the offspring, the spouse of the offspring, what is the control, is really important, because it's the genetic of the control that we compare to the genetic of centenarians. Okay. We're trying to find the differences between them. The offspring comes later because we want to see, okay, do you have the same genetics? And if you have the same genetics, let's see how you compare to your spouse, and are you going to do better?
And what makes this study different from other SuperAger studies?
Well, there are some studies that are looking at the genetic of centenarians around the world, but they don't have enough power, and they cannot really find all the relevant genes. Let me just say, I have a lab with animals too, right? And that's how I started my research. And we were discovering things with animals, and we were sure that this is going to translate to humans, but it didn't many times, right? We kind of were disappointed. We can cure Alzheimer in animals, but we still cannot cure Alzheimer in humans. And then it became apparent in the last few years that we can do better if we find genes in humans that either protect them from disease or accelerate their disease. And when we started doing that, we accelerated the whole process of getting the right therapy to humans, because we knew it's relevant to humans and not only to animals. And this is the same idea here. We were looking at the people who aging is slow, and therefore they're not getting to get diseases, or not at the same rate. And this is based on genetic findings. And once we have the genetic findings, we can apply it, we can understand it better and apply it to therapy.
Aha, okay. So would you say that, what would you say your primary goals of doing this research are? Is it to get those therapies down the line?
Absolutely. Look, there are many, it's nice that you said what's our primary, because there's a lot of things when you say to scientists, they're all, I'd like this and I'd like that. And we'll have it all available. By the way, this is all going to be available immediately on the web. So any scientist can come and do whatever they want to do to discover things. But if we want to say it as one sentence, this has to be translated to human health, right? We want to make sure that we're increasing health span of people, kind of dramatically, and allowing them to have better aging and better outcomes.
And I want to point out the use of the term health span instead of lifespan, because we don't just want everyone to live longer, we want you to live healthier longer.
Right, absolutely. And I think there's a sensitivity. And in fact, I realized from my own research that when I just say longevity, people assume, okay, you're going to live longer, but you're going to live sick longer, right? And I think health span for all of us is the major goal. But please realize that it's the same mechanism, okay? So if we're delaying, we're improving health span, we're also delaying death. So so they are both things, but sometimes I'm saying, our goal is health span. And if they ask me what's the side effect, I say longevity. Because, hey, maybe you cannot afford living so long, right? Maybe it's a side effect for you. So health span is really important to understand. If it wasn't health span, if we're just extending life without health, we have no interest in that.
Yeah. What does someone have to do to get involved in this study? How long is the process? What is the home kit like?
So what we're hoping, look, it's all a web-based study, okay? And immediately that shows you it's difficult, because how many centenarians are on the web? And really, I think our primary goal is to find those people, and the people who will find them are sometimes their grandchildren, okay? And the grandchildren will say, hey, I have this incredible grandmother and she's absolutely fantastic, and I would like to know why she's going so strong. And this granddaughter will help us register her parents, right, and her grandmother into the study. And when they register into the study, which is a very easy web registration, then we'll have an address and we'll have an envelope sent, and the envelope will be clearly explained and marked. We'll have descriptions of exactly what you want to do, probably with the help of the granddaughter or their parents. And really it involves spitting into a tube, and an envelope that is enclosed there will be sent back to our labs, where we'll process and take the science away from there. So I hope I'm thinking, did I explain it too long? It's not. It's really a registration, and it's as simple as we can get it. But please understand, this is such an exciting moment for us, because the thought of let's extend your health span, let's prevent your diseases, is really here and is already on the way. And we want to accelerate it and start treating you guys right now.
And how will the data from this study help age-related diseases? I assume it will be all in a data bank together.
Well, so let me make some points. First of all, I said that aging drives diseases, right? So you can, for example, you can be born with genetics for Alzheimer. There's one gene that's called ApoE4 that is a major risk for Alzheimer. You'll get Alzheimer when you're 60 or 70, you'll die when you're 80. When you're born, you don't have dementia. When you're 1 year or 10 years or 50 years, you don't have dementia. You need this biology of aging to get this disease, okay? So we want to interfere before. We have centenarians who are ApoE4 positive, and they're not demented. They're not demented and they're not dead, which shows you the power of targeting aging and expanding your ability for health span. I don't know if they'll ever have a cognitive dysfunction, but with this in mind, you understand that the data that we'll have on what genetics they have, how it interacted with the things that slows their aging, will be open for people to go and see. Some of us already have ideas what it could be. Some others are saying, you know, I'm not assuming anything. I just want to get all this data. And by the way, this data, when we're sequencing the genes of those centenarians, we have millions and millions of data points that can be looked at different ways, and questions can be asked in different ways. And we can do all of that and learn much more about aging, about the resiliency, our resiliency for diseases, and about really the mechanisms that allow people to do that, and to start thinking of drug development. You know, how do we target these genes so all of us can have it and live healthier and longer?
So other researchers will be able to access this too, and so it's kind of thinking in as an investment in everyone's future, because other researchers will be able to use it and make innovations with it. And this is all so fascinating. One last question I have for you, and then we should bring in Natalie. But one question I have is the goal for everyone to be a super ager?
You know, I think if you ask people, you know, you can ask people how old, you know, if you tell them you're going to be healthy for every day of your life and pick the age that you want to die, people will pick different ages. I picked an age 20 years ago that was 20 years longer, you know, older than me. And I still hold to these 20 years, you know, now it's 20 years ahead. I think everybody has a concept. So the answer is not everybody, wants to live longer, but I think people who you just randomly ask without any connection, if you tell them, we're talking about our ability to extend your health span, I think they'll become greedy and will want to live longer. We don't always agree to convince. We have a very famous guy who writes all the time in the papers that he wants to die when he's 75. Because why would we age? And we're trying to tell him, okay, but maybe we can move the age to 80 or 85. Is that okay? He said, no, it's 75. So not everybody is a believer, but we are believers because we see those people, and you'll see Natalie in a second. You know that her aging was stunned, okay? You don't expect her to really be her age.
And I think that's the perfect segue. Natalie is a participant in this SuperAgers study. And I'm so excited to hear your perspective on all of this. Natalie, thank you so much for joining us. And Dr. Barzilai, thank you for your input too. And we'll come back at the end with questions because I'm sure people will have some for both of you. Natalie, at first, I think we're all curious about this. What are your secrets to feeling healthy and vital? And what's something that you do every day that makes you feel well and happy?
The well and happy comes from having family. I think family is one of the secrets that we ignore or take for granted. I have been privileged and fortunate to have family around me, but we always did that from the get-go. growing up with mom and dad and brother and sibling and cousins and friends is so, it gives you the enthusiasm. And that enthusiasm helps with the growing up, with the aging, with appreciating life. I always tell my children, smell the roses. Not that necessarily there are roses. I'm just saying, just look at that sunshine, look at that tree, look at that bird. Not little things. Living in New York gave me an appreciation of people. People are so incredible. The man in the delicatessen, the man in the Chinese laundry where we took shirts, the painter who came and painted our apartments. I'm always fascinated by what people do, how they interact, how I interacted with them. And to me, New York was a neighborhood. It didn't represent the city, it represented a neighborhood.
I mean, I live in New York. I totally agree with that. And people really can make the difference in anyone's day. So I think that's a good reminder for all of us. Tell us your experience about with the home kit. What made it quick and easy for you to do the home kit?
Dr. Bizet said, the granddaughter, and she was the one who did it. And we stood around around the table, and she opened it and read the instructions. And like I said before, to take a little bit of moisture from your mouth and put it in an envelope and send it away, and realize that people are learning from that. It's mind-boggling that we have affinity with people that we never knew existed. It's really wonderful. So we happily did it, and they took care of putting it in the envelope. So I was just a participant, but they took care of the rest.
You were the primary participant. What advice would you give to someone who isn't sure if they should join this study?
Well, like I said before, who knows, maybe they have that particular little grain of sand that really was looking for that grain of sand. I mentioned Ponce de Leon before, because this has been going on for centuries, but now we're in a different place. Now we have the tools of medicine on our side. Before it was looking for a magic wand. No, it's not in the wand. It's in the medicine that may be afforded through these studies that will help people achieve longer life.
I love that. It's so true. That miracle, that fountain of youth that people are waiting for, it could come from this study and the information we learned from the genetics of it. How do you hope studies like this will benefit future generations, like your daughter or your granddaughter?
Well, just yesterday, my daughter celebrated 45 years graduating from medical school.
Oh, that's great. Congratulations to her.
Here we sat in awe. Where did 45 years go? So now she's 71, and my son became 70 on Monday. I had them a year apart. And all of a sudden, these people are now almost superagers. They're getting there. And they have the enthusiasm of youth. Enthusiasm, it's not just an empty word. It's, we call it zest for living, enjoying a child playing, and enjoying something that's very ordinary. That enthusiasm, I think, helps any person who's coming on in years or growing up. It's looking for the unknown. And my daughter entered very young age. She was a doctor by the time she was 25. And she said, I didn't know a thing. And here she got her degree and has persevered. And I thank God for it. And we go forward with knowing that science is there to help us, and believe in science completely, in the remission of diseases. Some of our family has gone through cancers, and because of the miracles of these science and the sacrifices of the scientists, that we have people in remission that are here because of that help. So what can we do for the SuperAgers? Join. I tell them, anyone that's a SuperAger, just join and be happy that you can be part of this wonderful search and journey.
Love it. Lastly, a question for you. What are some of the things that you're looking forward to accomplishing in your years ahead?
Well, the thing I'm see the benefit of having these grandchildren and great-grandchildren that call me up and share their days with me, that I can go on vacations, that we go to Puerto Rico, that we go to New York. In July, we're going to go to New York and hopefully get to a theater show and be able to do and see some of the old haunts. When I grew up, I want to take a little tour of the streets that I was able to walk, Fifth Avenue and 42nd Street. You got to go. So I'm hoping to be able to do that.
Excellent. Excellent. Thank you so much. I hope you're able to do those things too.
Thank you very
There are
much.
a lot of great
Thank you
shows
for
on
having
right
me.
now.
Thank you. Thank you, Dr.
Uh,
Barzilai.
Now, let's see here. We have some questions from our audience here.
The first three questions are perfect.
Okay, great. Do you want to start and tackle them?
Do you want to read or shall I read them?
I can read them. So the first one, we have one other one I want to start with is Nir, are there centenarian studies like the New England Centenarian Study, the Northwestern SuperAger Brain Study, collaborating with each other?
Oh, absolutely, absolutely.
Okay.
And the principal investigator of the New England Centenarian Study are also participating in our study, and they have their own study, and we're participating there. We're trying to be a community, and again, it's very important for us, and AFAR has just set it up straight. We're going to do the studies and we're going to post them in a way that everybody can harbor them and make really fast progress. So we want validation and we want other people to come in and other experts to come in, and it will accelerate all our science. So yes, the answer is yes.
Okay, great. Then we have to go to our Q&A questions here. What are the top predictive markers, genetic or factors, environmental/lifestyle, of a SuperAger?
So I will just give one example that might be a little bit surprising, but 60% of our centenarians have some changes in their genetics that blocks their growth hormones. Okay, now there's only one growth hormone, but there are many growth hormones. Okay, so please bear with me. But in our study, 60% have something like that. And its impact is remarkable in the sense that even when you take centenarians, they're already 100 years old, and you ask who's going to die first and who's going to die last, those who have these low growth hormone levels are the one who are going to live twice as long. They're already 100 years old, okay? But they're going to live twice as long as the others. I mean, twice as long the rest of their lives, right? Now, this is a concept that's really interesting because on one hand, growth hormone is always good for you when you're young. The higher the growth hormone, the less sick you are, the more successful you are. And somewhere at the age of 50, it changes. When growth hormone is high, you're doing really poorly. And why is that? Because when you go to the age of, over the age of 50 and you start having your breakdown of aging, you cannot invest your energy in growth anymore. You have to protect against this growth. So if you have lower growth hormone levels, it's better for you. So this is just kind of an example that is the scientific example, and there are drugs that are being developed to stop the action of those growth hormones. So this is, thanks for asking. I just chose this an example, but there are many others.
So interesting. You noted there were 3 theories. One is that centenarians did things right. 2 is the large genetic component. What is the third?
Right, and I totally realized that I skipped one. Well, the one that I skipped, though I came to it later, is it could be, you know, we have already changes in our genes that putting us at risk for diseases, for heart disease or for Alzheimer. I talked about this ApoE4 genotype, right? There are genes for Alzheimer's, genes for other diseases. And we thought, you know, maybe centenarian, you know, being centenarian is 1 out of 10,000 and 1 out of 5,000. Maybe they have the perfect genome. They don't have any of this garbage. And we found out that our centenarians have at least, or between 5 and 8 genes that should have made them sick. Like the example I gave eventually, the ApoE4, we have centenarians with ApoE4. So we don't have a perfect genome, okay? We don't have a perfect genome. Our genome, the genome of centenarians contains bad genes, but they're protected by the fact that their aging was slow. So those bad genes didn't come into effect, at least not in the periods that we're looking at. So yeah, it's for centenarians, it's not the environment. It's not because they don't have bad genes, but it's because they have other genes that slows their aging, like the growth hormone or like the other examples I gave.
Excellent. Our next question is about the cost of longevity drugs and how accessible they will be to everyone. Will they be very expensive? Is there an ethics component about this to your study?
And that's people are asking me that a lot. You know, we talked about the economy, macroeconomy, right? We said there's a value, there's a longevity dividend for living healthier and longer. But what is the cost of that? And AFAR is also running another study. I'm also involved in this study that's called TAME. It's targeting aging with metformin. Metformin is a drug that actually extends health span. Not as much as to be a centenarians, but several years of health span. And we're doing this trial in order to show the FDA that aging can be targeted, okay, which is another problem that we're dealing with. The FDA, aging is not a disease. So FDA is like, what do you want from us? And we say, well, we want to prevent a disease. So we are going to show them. But I'm giving this example because this drug, metformin, is the cheapest drug in the American formulary. Okay, it's really cheap. If FDA will accept what we're showing them, it'll be no cost for providers to give you metformin. Okay, it's true though that we'll have better drugs, combination of drugs, and the cost might be just as we see with other drugs, right? I mean, it will be expensive for several years and then it will go generic. It's not going to be different. There'll be much more expensive drug and much cheaper drug, and we'll find out how to do that. I think the motivation of healthcare providers to keep you healthy has such a big price on that I don't think the drugs, most of the drugs are not going to be very expensive for healthcare provider because they get so much benefit out of that.
Aha. Is there any relationship between hormones and exceptional longevity?
I just gave the example of growth hormones, right?
Yeah.
And I also said that I thought that just fixing all those hormones are going to be beneficial, but it's much more complicated than that.
Okay.
Part of the reason that some of our hormones are declining with age is also a protective mechanism. And it may be like with the growth hormone that we don't want to invest in growth. We don't want to invest in reproduction. We don't want to invest in other things. So we're trying to figure out what's the right period to use hormones. But if you just take older people and just give them hormones, you usually get into trouble, or also into trouble.
Natalie, I have another question for you. Did you participate in studies before, and did you have any hesitation about joining this one? Would you participate in additional ones if they came along?
Well, I didn't participate before, but I've been always interested, and I got my Facebook pad because of COVID. And so for entertainment, for my church services, and to keep up with the family. And one day, lo and behold, I opened up the pad and there is SuperAgers. So I read the ad and it said 95, and I said, well, that's me. So on my own, I called up and I got a very nice young woman named Lisa, I believe. And she explained to me what it was about. And I said, I'm willing to join if you want me. And here I am, and I thank you all.
Excellent.
I'm enthusiastic about it. I'm thinking that this is wonderful, wonderful, not just for the SuperAgers to pay attention to what it means to grow into longevity, not just because we get there, but how valuable the contribution of the person that came before us for the future generations. So I'm very enthusiastic.
Thank you, Natalie. That's another reason. The way you're talking is another reason why I want to dance with you at a certain. My wife is probably watching this, but you know, she got used to that. You're beautiful and you're smart, and thank you for helping us. I want to say I want to answer just another one. Is it okay, Kaitlyn? I've been looking at some of them, and all good questions, and I would love to answer after if I don't have time. But
I have one more about this study I want to answer. I want to ask you, and then I'll let you pick whatever you want to answer from the Q&A.
Terrific. Right.
So some people may be scared to share their genetic data in a study. Can you assure us all about the safety and the security of our genetic data for people who participate? If someone would be hesitant to join a study like this, what would you say to help change their mind? Or if you're a SuperAger and not a researcher, what would make you join this study yourself?
Absolutely. There's a concern about your genetic information, and the way we're dealing with it, the way genetic studies are dealing with it, is we're keeping your private demographic information, basically. We're keeping locked. All you'll have is the age and the sex of the subject. And this is enough to understand longevity. If you have a 60-year-old and a 100 years old, you know who's who. And this is the information that's going to be available. I want to tell you, though, when we ask, I don't know, we can ask Natalie, does she care if her information is out? I mean, what can they find out? That she's a centenarian?
You can have it.
So not everybody has the concern, but the people that have a concern should know there's an IRB, a review board that looks at all what we're doing and how we're going to store and how we're going to make it available. And it's not going to be, you're not going to be identified publicly with this information.
Exactly.
I would just say one thing. Let's say that Natalie has an ApoE4 genotype that puts her at risk for Alzheimer, and she's obviously she doesn't have Alzheimer. But somebody could argue that her children might inherit that, and maybe they're not going to be protected from Alzheimer, and they don't want people to know, right? So there's a reason to keep this information, but we can assure you this is not going to be out there.
Great. Okay, now why don't you take a stab at another question from the chat box that's striking your fancy?
Right. I want to answer David Gordon, who asked, are there any geographical regions would have statistically more centenarians than other region? And I really want to say two things. First of all, the blue zones, right? The blue zones, without getting into much of that, are zones, are areas around the world where people are everything. They're healthy, they're happy, they're doing terrifically. And clearly, a lot of that is environmental. Maybe there are olive trees or some fruits they're saying, but mainly is that environmental. But I do want to just say that before we have longevity genes, before we have all those medications, the things that we should do is maximize or optimize or improve our exercise, our diet, our sleep, our social connectivity. They all have underlying biology, and they're all targets that we can do right now without waiting to Natalie's results, okay? These are really the blue zones. Now, if you have an area like that, that is a blue zone, and you're going to live longer, then you have more chance also to become 100 years old. But I kind of learned to believe, I have some facts, but it's still a belief, that you don't get to be 100 years old without additional genetic help, okay? And each in the blue zone, some are getting 100 and some are dying when they're 50. So it's the statistics of the population, okay? So yeah, their geographical location, their blue zones, they're more centenarians in Japan and Okinawa than anyone anywhere else in the world. They're examples like that.
Great. I think we might have time for one more question.
Well, there's a very cute and related. Can a person who is a late bloomer in life be considered to be age later? And I think back, if you think of those growth hormones, so the people who have low growth hormone genetically had low growth hormone throughout their life. Okay, so maybe they're what you say, a late bloomer. Maybe they kind of got to their maximal height later than other people, and that then they have a benefit with aging. So there is a situation like that.
Okay. Let's see here. Do we have another question for Natalie? Natalie, you seem like a very positive person. Do you have any advice on how to cope with loss as you age, and outlive many of your family and friends?
Well, loss is heart-wrenching. There is no easy way to go through loss. Loss takes time. People say it's a process. It's not a process. You don't forget anyone you've loved in your life. You remember them on every holiday. You remember them when you're doing something special. And in a way, it's a way of sustaining. It's a way that sustains you through the grief. Not trying to forget, just remembering that they were with you for a time, and that you, by some process, did not go earlier than them. I used to think I want to go before my husband, but my husband went before me. And I've learned the process of caring for him, even though he's not here physically. I remember our hard times that we shared and also remember the wonderful times that we share. So grief is something that is very difficult to go through, but the love that you have for a person never leaves you. And that sustains you forever.
That's wonderful. And I think we all could use a little dose of your warmth and positivity in our lives.
Wisdom.
Yes.
And you know, we want to change aging, but we don't want to take wisdom away. So there you go.
I call it the experience of life because it's a journey. It isn't just get here to there. It's a road. Yeah. And that road leads us to many surprises. And that's living.
Thank you so much for sharing such a sensitive perspective on loss.
Thank you so much.
So beautiful. What's something you're looking forward to for tomorrow?
Tomorrow?
Yeah.
Well, tomorrow is Thursday. Natalie has appointments. Friday, we usually will go shopping, so it will have to be the day after tomorrow.
Okay. You're looking forward to Saturday.
The day after tomorrow.
Okay.
And Kaitlyn, I just want to say that for tomorrow, I hope that we have hundreds new candidates to join the SuperAgers study.
Amen.
Me too. And on that note, if you are a centenarian, please join. You can go to the website listed here, afar.org/superagers, or if someone in your family or a close friend qualifies, head over there. For updates on the SuperAgers Family Study, you can follow us on Facebook, LinkedIn, or X. You can also help AFAR continue to offer webinars like this at afar.org/donate. I really encourage everyone to support AFAR and all the work that they make possible. So thank everyone for joining us today and following along.